Today we will be talking about the motion of the stars in the night sky. We will try to do so with drawings and simple explanations about the way one can look at the sky. Because when at night we look up, we can see a lot of stars, planets, and other celestial objects from space. But if you look long enough, you can even see them moving. But how the stars move and sometimes don't set or are not seeable for a long time in the night will all be explained in this video. First off, we will talk about how different positions on the Earth create different perspectives to observe the night sky, therefore influencing what we can and cannot see. When you look from space, the Earth's axis, the celestial pole, is tilted. This angle is about 23.5 degrees. Around this tilted pole, the Earth then rotates counterclockwise, looking directly from the North Pole. This explains why the sun ascends in the east and descends in the west, which then also explains why clocks turn clockwise, but we will get to that later on in this video. So, the Earth rotates toward the east and has a tilted axis. Because the galaxy is formed like a giant pizza, the sun and planets move in roughly the same path in the sky, and this path is then called the ecliptic. What's more is that the celestial pole directly points at the star called Polaris. In our perspective, this star is stationary, and you are probably more familiar with it when we call it the North Star or the Pole Star. You can see this in the drawing shown. The blue line shows the northern celestial pole from the perspective of the observer, and also the altitude and azimuth are shown. Altitude is the angle with which you have to look up to see a certain star, and the azimuth is how much you have to turn around to the left or to the right. This point above you, so directly above you, is called the zenith, and it is precisely on the meridian, and that is a line going from north to south, which also splits the sky from the observer's perspective into precise halves. Now in this picture, you can see an example of the ecliptic. The perfect course depicts the perfect ecliptic, but usually it's more like the actual course, and that's the gray line where it says actual course, which means actual ecliptic. And what you can also see is in the middle is a pole, which figuratively stands in the ground and has a shadow. And now we have to look at the orange shadow, and as you can see, it moves from west to east, from left to right. Now this is useful to remember for later on in the video when we will explain why the arms of the clock move clockwise and not counterclockwise. Now let's imagine you're standing exactly on the North Pole, the exact place of the celestial pole. On your zenith then is located Polaris, and it is stationary, at least for the human eye and in our lifetime. If you look long enough, you see that the stars move around Polaris, which makes sense since Polaris is stationary. The stars then move in a clockwise direction around the North Star. This makes sense because the Earth moves in a counterclockwise direction. So what we see, what we think is moving, moves the opposite way, which is clockwise. Now positioning yourself more in between the North Pole and the equator, so in the middle of America, for example, the altitude of Polaris is lower, which means it's not on your zenith anymore, and you have to look more towards the horizon to actually be able to see it. The altitude of the star is then the same as your latitude on Earth. However, you cannot see the North Star the moment you are on the equator or lower. The Earth is then, well, quite literally in the way of you being able to see the star. The green areas on this picture actually depict the places where you would be able to see the North Star. Otherwise, you cannot see it. Hopefully this explained to you how we see the stars moving in the sky. Now we will be focusing on another comment made in the beginning of the video about why the arms of the clock move clockwise and not counterclockwise.
Why do clocks run clockwise? Well, this is because, as we know, the Earth rotates counterclockwise. This is what it looks like from the sun's frame of reference. Now, this creates an apparent movement of the sun that goes from east to west, as we can now see here. This was used in ancient Egypt, where the clock was invented, to use the sun's shade to mark the hours of the day. So as the sun kept moving, the shade moved clockwise, marking the hours of the day. This motion was then preserved when the mechanical clock was introduced around the 14th century, and this motion was kept on the clocks. This is why clocks nowadays have a clockwise motion. Now, hopefully, the overall idea has been clarified and you can start looking in the sky with the knowledge about how the stars and sun move. We hope that you've learned something new. We certainly enjoyed explaining it to you. Thank you so much.